Let's now talk about measures of spread. Now, as the name sort of implies, what it's saying is how spread out the data are. That's sort of what we're trying to measure. So just a little bit of a backstory about why this is even useful. So, if you have a long list of numbers, well, compared to that long list, if you wanted to know the average income in your town, then rather than having a long list of everyone's income, it's sort of a powerful thing to be able to just have a measure of central tendency, like the average, and have one number that sort of represents what you want the average income, right? But the problem with that is this, is that it doesn't tell you how spread out the incomes are. And so, for example, let's take a look at these two groups of people, and let's say this is their ages. Well, everyone in group 1's 20 years old, right? So if you take the average, add these up, divided by 4, you get that the average here is 20. And group 2, though, if you add this up, these four numbers add up to 80 as well. Dividing it by 4, you get 20 as well. So the problem is, if all you're using, so again, while the mean is a good sort of data reduction tool, instead of having a bunch of data, you have one number. That's sort of a good innovation. The problem is you lose too much information sometimes. So here, if all you know about these two groups is you're just looking at the average, you lose some insight. So that's sort of why we have this new way to measure things called standard deviation, this new measure of things called standard deviation. So standard deviation is the most common measure of spread that we're going to look at. So that's why usually when we try to describe a variable, we usually describe it by using its mean and its standard deviation. The mean along with the standard deviation, that combo of those two things, usually gives you a lot of information, almost all the information that you need about that variable, rather than just the mean. So what's the formula for standard deviation? The formula for standard deviation, notation-wise, by the way, this is a lowercase sigma. So that's what's used for standard deviation for your population. And S is what's used for standard deviation for your sample. Let's not worry about those nuances yet. There's another video that does that. But so the formula for the standard deviation for your sample is this. For your population is this. It's a square root sigma. Notice it can be confusing at times because this and this, they're both pronounced sigma. They're both basically the Greek letter for S. It's just that this is an uppercase, a capital S. This is a lowercase s, but they're both still sigma. So, so just be aware of that. So I'm going to call this sum instead of sigma. So yeah, so the standard deviation is the square root of the sum of xi minus x bar squared all divided by n. So when you look at this formula, step 1, freak out. What does it mean? It's confusing, right? But if we really think about it, here's what it's actually doing. So let's, the best way to get intuition behind what this is to actually find it is to actually do it, solve it out, and then you'll sort of gain some insight into what's going on here. So first, let's think about what this is even saying. So what this is saying is the representative term that's being added is each individual person's age, or whatever you're measuring, minus the average. So really, this is the difference from the average. How far off are you from the average? And that gives us some insight into what this whole thing is measuring. It's really looking at the difference. It's the difference between each observation and the average. How far is each observation from the average? Now it's squaring it. The purpose of squaring it is that way you don't have a bunch of positive and negative differences canceling each other out. For example, so let's actually do this. Let's actually solve sigma. Let me use blue for group 2. So let's actually solve for what the sigma is. So let's ignore the square root thing for now. We'll do that at the end. Let's just focus on this part of it. So, all right, the x bar we know is 20. So really it's just saying each of these minus 20 squared. So it's like 10 minus 20 squared, because that's x1. Then now the other one's also 10, so 10 minus 20 squared there. And this is 30, so 30 minus 20 squared, right? And then plus another 30 minus 20 squared. All right, so you're adding them up. There's 4 of them, right? And then you're dividing it by 4, and then you're taking the square root. All right, now let's simplify this a tad. This is negative 10. This is negative 10, and these two are positive 10s, right? So really, this is then just saying square root of negative 10 squared, negative 10 squared, plus 10 squared, plus 10 squared. Now notice what happens if we didn't square it. If we're just looking at, oh yeah, let's just find the difference, how far off each one is from the mean, add them up. Problem is, these two are negative 10 away, these two are positive 10 away, and so if you add them all up, it's just going to be 0. So by squaring it, you're actually forcing the difference to be a positive number. So that's why this negative 10 squared, it's still 100, because negative 10 times negative 10 is 100. This is basically 100 plus 100 plus 100 plus 100. So this is just 400. And then you could divide it, so essentially then you divide it by 4, and then you take the square root, and then you get what that is, right? So essentially, so we don't need to go too much into the math, but what's going on here is this. So the squaring is to make sure that, the negatives and positives don't cancel each other out. And the square root at the end is just to undo the fact that we squared it. But ultimately, so the main takeaway of this is, what does standard deviation mean? How do you interpret that number? And here's essentially what it means. Standard deviation, SD, is the average, because we're adding up and dividing by how many there are, it's the average distance from the mean. Average distance from the mean, right? Now let's actually calculate the standard deviation for group 2. It's going to be really easy, because the average is 20, so this first number minus the mean would be 20 minus 20, so that'd be 0. But then 20 minus 20, 0, 0, 0, which makes sense because basically there's no spread. This data set's not spread out at all. All the numbers are at 20. They're at the mean. So the average distance from the mean is 0 because literally everyone is at the mean. There's no distance from the mean. So again, just to recap, standard deviation, it's a measure of spread, and the interpretation of that number when you apply this formula, which looks more complicated than it is. It's not that complicated. It's just, how far off you are from the mean, square it, average them all out, square it at the end. The good news is, if you're somebody who's going to do, research or data analysis, you won't actually ever have to do this by hand, because computer programs will calculate this in like half a second for you. You enter, a bunch of numbers, you do standard deviation, enter, and then bam, it gives you that number instantly in a second. So you don't even need to worry about doing this, but it's important once in your life to at least see where it's coming from, see why it is the way it is, and then not worry about the details, but just focus on the concept after that, which is, again, average distance from the mean. That's what standard deviation is measuring. And so if you're, so the bigger the standard deviation is, the more spread out the numbers are. That's ultimately the main takeaway. The more spread out the numbers are, the bigger the standard deviation. A few other measures of spread are variance. Variance is literally the standard deviation squared. So it's literally the standard deviation that we just found squared, which literally just means do the same process, except don't worry about the square root at the end. So the variance doesn't really have a practical interpretation because the square messes up the units. But really, so it really is just like an in-between step to finding the standard deviation. It's like when you're finding the standard deviation, before you take the square root, the number that you have there is the variance. But the point here is that, just like standard deviation, the bigger this number is, the more spread out the numbers are. Notice, by the way, that standard deviation and variance, they can never be negative, right? Because they involve taking a square, which is always positive, and then adding them up, still positive, dividing, still positive, square rooting, still positive. So the point is that if somebody says that they did the math, they found the standard deviation was -3, they definitely made a mistake somewhere because it cannot be negative. The lowest it can be is 0, and that's if everyone's at the mean. Same with variance. Another measure for spread is called the range, and that's literally just the maximum value minus the minimum value. So it's really just saying, so the more spread up the numbers are, that just means, yeah, the difference between the lowest income and the highest income, or the lowest age and the highest age, the bigger that difference is, the bigger the range of the numbers are. So that's all that is. And there's one more called IQR, Interquartile Range, but again, that's not as commonly used. What matters more is the 5-number summary, which is in the next video.